Hello everyone, welcome to another video from the AI Loop. Today we're going to be talking about pre-training objectives. So let's get on to it. Well, what are pre-training objectives? Pre-training objectives in a simple sense are something that gives your model a context of the data that you're dealing with for your specific task. So before getting into the pre-training objectives itself, let's try to understand an example of where they're derived from. Well, in the start, I'm going to be talking about transfer learning, if you're familiar with this concept. So, if you remember during the time when CNNs were becoming really popular at object detection or at object classification, especially with things like AlexNet or ResNet, these models showed up and like they made a big difference to how good they were at classifying certain images. I think it was the ImageNet dataset. So what really happened was like people used to define architectures, and let's consider this to be a CNN architecture, and this is the main model. And what the architecture or the flow of the model used to look like is that there's a main architecture, and then you have like a bunch of fully connected layers, usually two, that are help to classify an image, right? And this is the fine-tuning layer. So what they did is like create an architecture that was specific to that specific model. It is used to have like millions of parameters, and then they just put like fine-tuning layers at the end, which helps classify the model. And what they do is that when you release, or like when you as a user want to use certain model that has been fine-tuned on a classification data set or ImageNet data set that helps classify, what you do is you chop up this part, you basically eliminate the end layers, and you basically take the main part that generalizes the whole stuff, take that particular model, and then you add like the additional layers that you want to use. These additional layers depends on the task that you want to do, and this is the concept of transfer learning. It seemed to have many benefit, and it also showed like a great performance improvement over the previous approach of just taking a whole big architecture and training the model on it. Now there are like many uses or many specific advantages of using the transfer learning, and specifically the main idea here is that when you have like a model that is trained on something and you take it to fine tune a particular task, it really helps you eliminate the amount of the data that you want to work on. So let's understand this in the context of a pre-training objective. Well guys, for the pre-training objective, let's consider two specific cases of where would you want to use that. Let's say first one, you have a mapping from A to B and you want to train something to map all the way from A to B, and let's consider it to be a movie reviews data set, and you have like sentiments like let's say happy or sad or whatever that reaction is. And you when you try to map from A to B, and let's say according to the modern standard, like let's say you have 5,000 data points, and according to the modern standards, these data points, like 5,000 data points, is like a fairly small number. So you try to train a model on it and then it does not perform well. What would you do? And let's consider a second case. In this scenario, let's consider a person who wants to learn chemistry, and they've enrolled themselves in a course or wherever they want to learn, and the instructions in the course are being delivered in English. And let's assume that the person is not aware of the English language. Now they have two problems. That's the first one is to understand the language English and then try to figure out the concepts of chemistry, right? Like this makes it very difficult for the person to learn chemistry. I mean, the main intention is for the person to learn chemistry, but English has become a barrier for them because the course is being delivered in English. Now, these are two scenarios where we can consider pre-training or the context to be very helpful. Let's say you have the first issue, or for simplicity, let's consider the second case. If the person already knew how to, or already knew the English language and how to speak and write, it would have made them a lot easier to learn the language, to learn the chemistry. Now, this is particularly the case where we would want to use of pre-training, or like this is particularly the case where context plays a very important role. And even in the case of like the first example, let's say you have movie knowledge, or like the model already is aware of the terminology that is used in the movie section, or like words like actor or actress or ratings and reviews in the genre, it would have made it, or it would have made a lot of sense for the model to classify or to be able to classify and learn a movie review to sentiments with such a small data set. Now, this is the idea behind pre-training. So, what pre-training does is that it gives you the contextual information. Well, generally, it's become very famous with large language models. If you've watched my previous videos on BERT, you know it's been usually trained or pre-trained on two particular objectives. So the steps to pre-training any model is that you take a model, you have an input and an output for this model, but this model has been initialized with random weights, right? So it's been initialized with random weights, and now you would want to collect data set. Let's say for the first data set, like for the first case where we have movie reviews classification task, what I would do is that I would go to websites like IMDb or Rotten Tomatoes and then just like scrape the data, right? So now I have like a bunch of data that corresponds to the terminologies or that consists of terminologies in the movies. Now, this data set would really help my model understand the context of the movie sector, right? Like, or whichever sector that we consider this to fall in. Now, how would I make my model aware of this data first? And this is happening even before going to the actual task. And that is the whole idea, that to give a model heads up about the type of task or like the contextual information. So what I would then do is to choose a pre-training task. Now, pre-training tasks are the way that you would want to, or you would want your model to learn the corpus that corresponds to the type of task you're doing. So basically, you take the model and you have the data set, and you choose a pre-training task and train your model on the pre-training task until you receive a satisfactory performance from the model. Now, there are several pre-training tasks, but I'm going to talk about some of them and give you a very high-level overview of how they work. Well, all the way we have, let's talk about three pre-training tasks. The first one would be the masked language modeling. Now, masked language modeling is nothing but like, let's say you have this sentence such as the movie was good. What you would do is that you would mask one of the words. You would basically take words like this and just mask it and ask the model to predict, and then basically it predicts something, and then you calculate the loss between this actual word and the predicted word and do the back propagation until you receive a satisfactory performance. You just keep doing this. And the second one that we're going to be talking about is, let's talk about fill in the middle objective. This is a very famous objective that has recently been very famous. So if you consider the first case, basically the idea here is to just fill up this particular word, right? Now that is like a fairly simple task. I mean, as a human too, like if I ask you to predict a certain word, it would be fairly simple. But what makes it challenging for a model is that, let's say I give you some context in the front, and then I give you some context towards the end, right? And let's consider this to be the start and this to be the end. Now I have like some sentences here, like let's say the movie and let's consider something like to be good or something, and I give you a set of words in the end and set of words in the start, and I ask you to predict what's coming in the middle, right? And this is the objective or the aim of the fill in the middle. It's to basically map the start to the end through the sentence, and this really becomes tricky for the model to achieve and hopefully perform better. Like if it performs better in this task, it has learned like good knowledge of the data set. And the third one usually would be, let's consider like a simple case, a classification task, right? Basically you have like a bunch of supervised tasks where you have like task A to B, and then you just ask it to predict the class, and then you would store those weights. Now this is the end goal of the classification task. If you observe, basically there are two things. Like the first two are categorized into the unsupervised sector, and the third one is categorized into the supervised sector. And that is the difference between these two. The thing is that when you have unsupervised pre-training objectives, what really happens is that you do not have a limit on the, or you do not have really a burden on the data side, right? Because for unsupervised objective, you do not need to manually have labels for everything, and you just like like collect a bunch of data set and then just like fine tune it on that, sorry, pre-train it on that. For classification tasks, you need to have a label data set. That's the disadvantage. And unsupervised pre-training has become very famous in the recent times, with so much data going in for pre-training to make the model understand the language specific task or whatever that task that you're trying to do. Now let's try to understand some of the advantages or some of the things that you could do with pre-training. Like what apart from giving the context, what does it help in? Well, one fine case that you could look at is the efficiency, right? And what I mean by efficiency is that you as an individual developer, or let's consider organizations who do not really have access to good resources, right? Because usually in unsupervised fine tuning, like this pre-training, which is very famous, what happens is you collect data sets that are huge. The data is like basically in terabytes, and you do not really have the resources or the time to do that particular pre-training task. And this would really take off the burden from you. Let's say you have, and I mean, even consider Hugging Face for that case. It provides us with pre-training models, and then you just like take the model and put additional layers on top to fine tune it. Now this is one of the main reasons that pre-training or transfer learning has been very effective. It also takes the burden of you to train your own model and like allocate that resources when you as a developer cannot really afford to do that. And apart from that, it works, right? Basically, this is something that I really look at when like evaluating tasks or approaches that has been proposed to do things. It basically works. There have been studies saying pre-training really works. Of course, I think I've read like one contrary study which says pre-training does not matter that much when you compare to the quality of the data that you're using and the number of layers or the size of the model. But that is like a different case. But basically it works. Pre-training, you have the model and you have like the contextual information that is associated with it, and you just add additional layers. Basically guys, what you do is you either freeze or unfreeze this. If you unfreeze these layers, you would have to train the whole thing, or you just like fine tune it on these particular layers. But I think the better approach would be to retrain the whole thing based on the task that you want to do. So there are two reasons that we looked at. It's efficient, it works. It also eliminates from the environmental aspect. You don't have to burn GPUs in order to train it. So from that side, it is really helpful. Let's look at some other things, other aspects, apart from like the language models or like plain English text. Where could it be used? Well, there are some pretty interesting pre-training tasks when we consider code. Code is particularly tricky because it consists of syntax and structure, and you usually don't get the liberty that you get in like the usual language, so the framing is kind of different. Some of the interesting pre-training tasks that I've seen in code is that usually what they do is they take code and then like they convert it or parse it into graphs, and they give this to the language model, this data to the language model as a pre-training task. And the task they usually do is that given a graph like this, basically they build dependency graphs where like you would know one variable, like what variables are dependent on which other variables in the whole graph. And basically they would ask the transformer or the language model to predict this particular node. They would like mask this so that it understands the dependency information, it derives that information. And apart from that, master language modeling is also famous in the code. And one more thing is the variable name prediction. So basically variables are something that give like the semantic sense to the piece of code, right? Let's say you write a function, you give like a variable name like get char or whatever, and this variable name usually defines the meaning of like what the function is doing. And in order to be able to predict this, you ideally have to understand what the function does. So that is the intuition behind asking a model to predict a variable name. So variable name prediction is also a famous task that is used in code pre-training. Well, these are the things regarding pre-training tasks. Some other things where I could lead you is like BERT. It uses next sentence prediction. That's a classification task. Or models like autoregressive models like GPT. They use like the next word prediction as the pre-training tasks. And there are also certain tasks where like you have autoencoders. You basically take a bunch of text, like a sentence or whatever, and then convert it into vectors and ask the model to convert the vectors back into the sentence itself. So these are some other pre-training tasks that you could do. I really hope you found the video to be helpful. So next time when you do not have enough data, you know what to do. Well, I'll see you in the next video. Thank you for tuning in. Please subscribe to the AI Loop. It really helps motivate us to create more content, and comment down below if there's anything specific that you wanted to request for.